Alright, welcome to the Unit 5, the Radicals Test Review. Alright, let's get started on this. Hopefully it doesn't take a long time. Hopefully you get something out of this. So when we do square roots, we're simplifying. We gotta think about what's the biggest perfect square that can divide out of 8. Well, that's 4. 4 times 2, mn, and we'll work with that p cubed because we can simplify that also. We have the square root of 4 is 2, so that's going to be 2 multiplied on the outside. The square root of p cubed, I have 3 p's, and you have a pair, because it's a square root. For every pair, it could come out. And what's left then is a 2 from inside, an m, an n, and still a p. So we have negative 6 times 2 is negative 12, p, square root of 2m, n, p. Final answer. Number 2, we have a cube root. So I think about what's my biggest perfect cube root, or cube that can divide out, and that's 135 divided by 27 is 5. And cube root of 27 is 3. Cube root of 5v, that's negative 21 cube root of 5v. Number 3, an SOL question. We have the cube root of 162. Again, it's a 27 is the biggest perfect cube. Times 6 is 162. And x is 6, y to the 7th. We'll work on that in a little bit. Cube root of 27 is 3. Cube root of x to the 6, we have 6 x's. And it's a cube root, so we need groups of 3. So there's 2 groups of 3, so it'll come out as x squared. The y to the 7th, we have 7 y's. How many groups can you... How many groups of 3 can you take? Well, there's 2, so it's y squared. And what's left over is 6y. So that's our final answer. Nothing to simplify from there. For B, we're combining. So the first thing I would do is if there are any like terms, and like terms are determined by the square roots, and that what's underneath has to be. So square root of 54, I don't see any other ones. Square root of 2, I don't see any other. And the square root of 18, I do not see any other ones. So I'm going to start off with simplifying. Square root of 54 is 27 times 2. 18, biggest perfect square is 9. Wait a second. Back it up, back it up, back it up. Biggest perfect square out of 54 is 9. Whoa. 9 times square root of 2, and 9 and 2. Okay, now I got this. Square root of 9 is 3, square root of 6, minus square root of 2, minus 3 square root of 2. 9 square root of 6 minus square root of 2 minus 3 square root of 2. And like terms, we do have like terms. We have square root of 2 and square root of 2. So we have a negative 1 of them. And we're subtracting 3 more, so that's a negative 4 square root of 2. And then in front we have the 9 square root of 6. Those are not like terms. That's your final answer. Number 5. Cube root of 81 is 27 times 3. And 2 cube root of 4. Sorry for the beeping in the background. And cube root of 27 is 3. And then we have like terms here, so it's a minus 5 cube root of 4. No other like terms put together, and that is your final answer. All right, number 6. So with multiplication, we have multiplication now. So with multiplication, we multiply the outside coefficients, and we multiply the insides. So there's no like terms like that you have to worry about when you multiply. Multiply what you can together, and then we simplify. So we have the square root of 240. 240. Biggest perfect square is 16. 16 times 15, and k squared. Square root of 16 is 4. Square root of k squared is k. And what's left is 15. So that's going to be a negative 40k square root of 15. Number 7, we're going to distribute. So 4 times 5 is 20. 6 times 6k is 36k. 4 times 2 is 8. 6 times 2k is 12k. Now we we after you multiply, you always simplify. So the square root of 36 is 6. Cannot break down the square root of k. We have 8, or 12 is going to break down at 4 and 3. Certainly could have brought that 4 out as a 2 right now, but I'll just write a couple more lines here. So we multiply 20 times 6 is 120. 8 times the square root of 4 is 2. Square root of 3k. So we have 120 square root of k plus 16 square root of 3k. Because what's underneath the radical is not identical, they are not like terms. So this is your final answer. All right, number 8. I know we did this in class, but let's work on it now. So a binomial squared means that binomial times itself. So you have multiply the first 2 together, you get 4. Multiply the outsides, multiply the inside. So the radical is 9. 3 times 3 is 9. X times x to the 5th times x to the 5th. Add those exponents when you're multiplying like bases. And then we have 2. So multiply 2 times negative 2 is negative 4. Multiply the insides. There's nothing to really do besides write the y next to the 3x to the 5th. Now we multiply negative 2y times 2. Square root of 3x to the 5th y. And then multiply the last 2 here. So we have positive 4 square root of y squared. After you multiply it, now we simplify each individual term. Square root of 9 is 3. Square root of x to the 10th is x to the 5th. And we have minus 4. I'm going to simplify the x to the 5th, which is x squared, square root. What's left is 3xy. And it's the same thing with our next term. So we have x squared, square root of 3xy. And the last term, we have the square root of y squared is y. So we have 12x to the 5th. Now you have like terms here to be negative 8x squared, square root of 3xy plus 4y. Then we have, next we have 6 times 5. Good. 6 times 5 is 30. 6 times the square root of 7 is 6 square root of 7. Square root of 7 times 5 is a 5 square root of 7. And square root of 7 times the square root of 7 is the square root of 49. Or you could just put 7 there. After you multiply, you simplify. So we have some like terms we can put together in the middle here. We have 6 square roots of 7, and we're adding 5 more square roots of 7. So total we have 11 square roots of 7. Square root of 49 is 7, and we still have like terms. So we got 30 plus 7 is 37 plus 11 square root of 7, which is D. All right, on to 5C. So for 5C, number 10 here, we can work it out 2 different ways. You could multiply by the square root of 2 over the square root of 2 to undo get rid of the radical in the denominator. That's actually not the fastest way in this case. If you notice that if you put square root over to 72 and 2, square root of 72 is, or 72 divided by 2 is 36. Square root of 36 is 6. That's your final answer. Now, if you did it the other way with multiplying by the square root of 2, you're going to get the same answer. It's going to take a little longer. So number 11. I know, again, we did this in class, but let's work it out again in case you want to see it again. This one, first, you might think, why didn't I just start that out like the other one? We can. So we could start out like this, and n squared can divide by n squared, and that could be simplified. So then you'd have the square root of 3 over the square root of 2. But we still have the square root of 2 in the denominator. So in the end, that didn't really do much for simplifying. A little bit it did, but here's how I would work it out. If I can't see that I can divide out and the radical in the denominator, I'm just going to multiply by the denominator. It's a square root, so I need 2 of them. Well, there's 2 denominators. Multiply the numerator by the exact same, so you're multiplying by something that's equivalent to 1. When we multiply here, we have the square root underneath the radical. 2 times 3 is 6. N squared times n squared is n to the 4th. In our denominator, we have 2 times 2 is 4. N squared times n squared is n to the 4th. Add those exponents when you're multiplying like bases. Look to simplify each radical, so every time you multiply, you always look to simplify. We have the square root of n to the fourth, which is n squared. And then in the denominator, square root of 4 is 2. Square root of n to the fourth is n squared. Now, the last step here, we have n squared and n squared out in front. And n squared divided by n squared is technically it's 1. But I'll show you. And then 1 times the square root of 6 is square root of 6. And 2 times 1 is 2. Most of the time, teachers or professors will do something like n squared divided by n squared. They'll just cross it out. But it's really 1. All right, number 12. If I can get this. All right, I see a monomial in the denominator, and I see a square root. So I need to multiply by the square root to get rid of it in the denominator as your final answer. We have a binomial in the numerator. We have 3 square root of 24 when we multiply that out, and we have 3 square root of 36 divided by 3 square root of 144. Simplify each term. We have 3 square root of 24 is 4 times 6. Square root of 36 is 6. And the square root of 144 is 12. So we have 3 times 2 square root of 6. I'm really drawing this out. You can definitely skip some of these steps. And then 3 times 2 is 6. Square root of 6 plus 18 divided by 24. And we look at each of our terms, our coefficients, and see, can we simplify them? And we actually can. We can divide them all by 6. So that's 1. 18 divided by 6 is 3. 24 divided by 6 is 4. So my final answer, I don't know why I went through the light. So 1 times the square root of 6 is square root of 6 plus 3 divided by 4. And you see the denominator no longer has a square root, so that is simplified. All right, number 13. So this one, we have a cube root here. With a cube root, we cannot just multiply by the cube root of 5v. That would give us 25v squared, and that is not a perfect cube. So that is not going to work. So you can multiply by another cube root of 5v. That way we have 1, 2, 3 cube roots of the exact same. That would be 125v cubed, and that will simplify. What I'm going to do, though, instead of multiplying by 2, I'm going to think, what can I multiply 5v by to get it to be a perfect square? And 5, if you multiply 5 times 5 times 5, that's 125. And then v times v times v is 125. So when I do this, I'm going to multiply by the cube root of 25v squared. And you'll see in the denominator, I'll multiply that out first. When I multiply these two out, I get 2 cube root of 125v to the third. And cube root of 125 is 5, and the cube root of v to the third is going to be, so this denominator is going to be 2 times 5 times v. So the cube root goes away, so it's perfect. In the numerator, this is going to get a little wild. Multiply, so we got to distribute in. So we have 5 cube root of 25v to the fourth, and then plus 4v squared cube root of 25v squared. I do have a little bit more room over here. Looking at simplifying, so looking at the numerator, I have the v to the fourth I can simplify. So it's going to come out as 5v cube root of 25v. And then we have plus 4v squared square root of 25v squared over, oh, it's already over this denominator. Let me rewrite this somewhere. So we have 5v cubed. Nope, that is not right. That is 5v cube root. I just wrote this too small, so it's hard for me to see. plus 4v squared cube root 25v squared over, and 2 times 5 is 10v. Now the last step is to see, can I simplify, I just highlighted too much, 5v, 4v squared, and 10v. Is there something I can divide them all the terms by? 5, 4, and 10, no, but I have v divided by, I can divide them all by v. Did I do that right? Yes. V divided by v is 1, v squared divided by v is v, v divided by v is 1. So we can put 1s here, and then be times. So what's left is 5 cube root 25v plus 4v cube root 25v squared divided by 10. That's your final answer. All right. Number 14. We're going to solve here. So first you have to isolate, get the square root radical by itself. Then we would undo the radical by squaring. Then solve the remaining equation. Because we do not have a quadratic, we don't have to check it. If you'd like to check it, you can to make sure you're right, but you don't have to. Because there was nowhere in that problem was it there an x squared, ever. All right, next problem. The radical is already isolated, so we square. Well, we already have an x squared, so there's our quadratic. So we have to add x, subtract 42, subtract 42. So we have x squared plus x minus 42. So I always want to get my a term positive, because that's going to be really make it so much easier to factor. So for the factors here, so we have to think what two numbers, since my a is 1, the shortcut is what two numbers multiply to c, so negative 42, that will add to b. So it multiplies the negative 42, that adds up to 1, and that's positive 7 and negative 6. Those are my two numbers I'm going to use when I factor. You can do the whole Punnett square if you'd like, but your factors are going to end up being x plus 7. Well, let me rewrite this a little bit better. So the 7 and the negative 6 are your second terms of your factors. First terms are always going to be your x and x. Set each factor equal to 0 and solve. And then we have to check them. So let's do a quick check of these. So we go back to the original problem before we did any math, and we substitute in. So I'm going to substitute in negative 7 and see, will it work if I simplify both left and right side of the equation. So left side is already negative 7, perfect. Right side is going to be 49. Square root of 49 is 7. Does that equal negative 7? No, it doesn't. That is extraneous. You can either cross it out or write extraneous next to it. And then we got to check 6. So let's do 6. 6 equals square root of 42 minus 6. 6 equals 6? Yes, it does. There's your final answer. That is our one answer to that problem. Number 16. The square root is isolated already, so we square. So we have 4k minus 3 equals, so square means times itself, so we have k minus 2 times k minus 2. K squared minus 2k minus 2k plus 4. You have a quadratic, so move all the terms to the same side, keeping the a positive. So we get 0 equals k squared minus 8k plus 7. Again, now I have my a, b, and c here. A is 1, so we do what two numbers multiply to c that add up to b. That might look weird that it can multiply to a different number, or it looks like a smaller number, but really you have negative 7 and negative 1. Those are your two numbers you're going to use. So in our binomials, it'll be a -7 and -1. Does not matter the order you write those in. And the first terms of each binomial is going to be k. And we set each binomial equal, or yes, each binomial, each factor equal to 0, and solve them. And quick, easy, get a 7, 1, and now we gotta check it. So check, go back to the original problem before any math was done, and let's put in 7. And 28 minus 3. On the right side, 7 minus 2 is 5. 28 minus 3 is 25. Square root of 25 is 5. Does 5 equal 5? Yeah, it does. So 7 is an answer. That's awesome. Let's check 1. So when we put 1 in, we got square root 4 times 1 minus 3 equals 1 minus 2. 4 times 1 is 4. Square root of, or 1, square root of 1. My goodness. It's Friday, people. Struggling. Square root of 1 is 1. Left side, that's going to be -1. -1 does not equal -1, so that's no good. So that is an extraneous solution. You can either write, just cross it out, or you could say it's extraneous. All right, number 17. Is the cube root isolated? Sure is. So now you undo the by cubing, cube, get 1/4 x plus 3 equals 2 cubed is 8. Subtract 3. This is actually another SOL, released SOL question. Undoing a fraction, you multiply by the reciprocal. That is not the reciprocal. 4/1, which is 4. And we get x equals 20. Did not deal with a quadratic, so we don't have to check it. And the last problem, we do have to isolate. And you're like, it's not a radical. Well, it actually is a radical, just in exponential form. When you are undoing a radical or an exponent, you multiply by the reciprocal. So we're going to raise this to the 4/1, which is 4. So we're going to raise it to the 4th power. What's going to happen? I'll show you this. Not something you need to show, but multiply 1 times 4 is 4. 4 times 1 is 4. And then on the right side, I'm just going to leave this 5 to the 4th for now, but we have 4 divided by 4 is 1. Well, what's 7v plus 2 to the 1st power? That's just 7v plus 2. So what happened is the exponent went away. 5 to the 4th power is 625. Then we subtract 2. Divide by 7. And we get the v is going to equal 89. Now, if you didn't get that, here's another way to do that, approach that same problem. The denominator exponent is your radical, so it is a 4th root of 7v plus 2. The exponent, so the denominator is your radical. The exponent is your exponent underneath the radical. So it's to the 1st power. That equals 12. Oh, I forgot the plus 7. And so when you're doing this, you still would subtract 7. And we get 4th root of 7v plus 2 raised to the 1st. Raised into the 1st doesn't do anything. Radical is isolated, so you multiply by 4, or raise it to the 4th power. And then you have 7v plus 2 to the 1st power, which is 7v plus 2. And now we're at the exact same spot as we were down here. So it's going to be the exact same work. So v is going to equal 89. We never had a quadratic, so we don't have to worry about checking it. And remember, we also have 5e, which is graphing radicals. Take a look back at your classwork. So look at your classwork. We had 2 days of it. We had 5e and 5e continued. Take a look at that classwork for good examples for the test. We got graphing radicals, and then we have domain and range.